Hi everyone, we welcome you once again to our basic mechanics series. Kindly subscribe to our channel, like, share, and also let us know of your comment and suggestions. Today we are continuing with our basic mechanics series and we are looking at moment of a couple. That is resultant of couple 2D. Quickly, let's look at our question and how to solve. Determine the resultant couple moment of the couples acting on the beam below. Now, from this question, you realize that we have two couples acting on the beam, and we are asked to find the resultant couple. How do we go about that? Yes, let's see how to solve our question. We have been given, when you look at the screen, we have two forces, one in this direction. So we can say that this and that are forming a couple because we said that couples have the same magnitude, but they act in the opposite direction and they are parallel to each other. So we can say that this and that are couples. And then we can also see that this, what we have here and what we have there are couples. So at least in this question, we have two couples, which we can find a single couple to represent them. Don't forget that this question is a 2D question. And when you are given a 2D question, you can either decide to use the scalar method or to use the vector approach. In this question, we are going to use the scalar approach. But first of all, we see from the diagram that some of the forces, the force here and the force there, are not in the x and they are not in the y as well. So in that case, we said that anytime you get a question like that or a force like that, you resolve the forces into components. Quickly, let's resolve those forces into components. Yes. So we are saying that we are going to resolve these two forces into components. Now we can see that this force is starting from this point here and ending at this point. So it means that if you want to get the x and the y component, we are going to move in this direction for x, and then we will move down for y. You move down for y. And then in the same way, this is the same as that. So in this case too, we are going to move this direction for our x, and then we move this direction for our y. From here, we can see that we are given that the horizontal distance is 4 and the vertical distance is 3. So we can see that this side is 3, this side is 4, and the hypotenuse is 5. Therefore, if you want to get the y component of the force, if you want to get the y component of the force, the y component of the force, so F of y, will be equal to the vertical distance, which is 3 over 4, 3 over the hypotenuse, which in this case is 5. So you are going to get 3 over 5 times the force, which is 350. And from here, we can see that we are going to get 280 pounds. 280 pounds. We can also get the horizontal component. We are told that the horizontal distance is 4 and the hypotenuse is 5. Therefore, our F of x, which is the horizontal component of this force, is going to be 4 over 5 times 350 pounds. And from there, sorry, our y component was supposed to be 210. 210. Sorry for that. And our s component is 280 pounds. 280 pounds. And because this question is two-dimensional, so what is going to happen is that we said that anytime you have a force in one axis, let's take it that this is x-axis, and the perpendicular distance between the two couples is in the y, then we said that our rotation is always going to be in the z. Our rotation is going to be the z. So in this case, because you have only x and y axis, all the moments which are going to be produced will be in the moments which are going to be produced is going to be in the z axis. So let's determine our moment quickly. So our moment MO always indicate the direction. So our moment is, we are taking the anti-clockwise to be positive. So our moment is going to be, we pick this couple here, and we know that the formula for finding a couple, moment of a couple, is the perpendicular distance times the force. Take note of this, the perpendicular distance times the force. So here you can see that between this and that force, the perpendicular distance between them is 3. So it means that our moment for these couples here is going to be 3 times 150. Then we have also stated that anytime you are using the scalar method to determine the moment of a force, the direction of the force is not important, and the direction of the distances are also not important. But when you are using the scalar method, the only thing which is important is to determine whether the force will rotate the object in the clockwise direction or in the anti-clockwise direction. If it is anti-clockwise, it is going to be positive. If it is clockwise, it's going to be negative. So in this case, you can see that our force, these are our couples. So you can just use one of the couples. Just use one of the couples to determine whether it will be clockwise or anti-clockwise. So here we can use this force here, and then so let's take it that our force is applied here, and then you see the distance between them is from this point to that point. So if we draw our distance like this, you can see that if the force is applied in this direction, it is going to rotate this object in this direction like this. Let's take it that this one is a fixed point and our force has been applied here. So it's going to rotate the object in this direction, which is going to be in the clockwise direction. Therefore, we can say that our 3 times 150 is going to be negative. Plus, now let's go to our force which we have resolved to x and y. So you can see that here, the y here, this is where the y is being applied, the y component of this force, and the y component of this force is also here. So you can see that here the y components are also forming a couple. The y components are forming a couple. One is coming down, one is going up. And the perpendicular distance between them will be from this point to that point. And so we can also say that the perpendicular distance is 6 times the force. So this is, we have already found that the force in the y component will be 210 pounds. 210 pounds. That is what we had already found. So we are going to get it to be 6 times 210. And now we determine whether it is going to be clockwise or anti-clockwise. We said that take one of the forces to determine. So the perpendicular distance is here. From this point to that point is the perpendicular distance between the two forces. So here we can see that if the distance is here, and let's take the force which is down here. So if I applied a force in this direction, you can see that here, this is a fixed point. You can see that this force is going to rotate this object in this direction here. And this direction is the anti-clockwise direction. Therefore, our moment will be positive. And in the same way, we can also get a moment for our S component. Our S component. So this is our X. This is our S component here. So it can also be put in this direction. It's the same thing. S can be put in this direction, and the S component here can also be put in this direction, in this side, in this side. So you can see that what we have here and then what we have there is also forming a couple. And we can see that the perpendicular distance between them is from this point to that point. So we can have our moment for that one to be, our X is 280. Our X is 280. So we are going to get our couple for that is going to be 280 times the perpendicular distance between the two horizontal forces, which in this case, it is 3. It is 3. So from here, we can simplify, but let's determine whether this will cause a clockwise rotation or anti-clockwise rotation. If my horizontal force is applied this way, and this is the distance, look at it, the distance is here, the distance is at this side. Therefore, if I have my distance here, you can see that this force is going to rotate this object here in this direction. And this direction is the anti-clockwise direction. Anti-clockwise direction. And from here, we can quickly compute for our answer. We have, this will give us negative 450, and this will give us 6 times 210. We can easily calculate that. So that is going to give us 1,200 and 1,260 plus 280 times 3, which is going to give us 280 times 3 is going to give us 840. And so therefore our resultant moment is going to be 1,650 pounds per feet. Pounds per feet. And this will be our resultant single moment. And we have said that because it is a 2D object, so all the rotation is going to be on the z-axis. So this will be in the k-axis. This was very simple and very easy to understand. If you have any comments, any questions, any suggestions, you can let us know at the comment section, and we will be glad to help you to understand the concepts which were applied. So once again, thank you for watching. Kindly subscribe to our channel and hit the notification button. Bye bye.